Hello, this is Pablo Pasos from Cabo Labs Health Informatics, Standards and Interoperability. What I will do in a minute is to show you the newest version of the EHRServer from the web console perspective. The web console is the administrative user interface. It's for managers, it's for administrators to manage EHRs, organizations, clinical documents for patients, etc. And we are going to do a small walkthrough the latest version of the server, the EHRServer. And here on the cloud EHRServer.com website, you can find more information about the EHRServer. You can find information about the SaaS plans, the software as a service plans. These are subscription plans based on the EHRServer. The EHRServer is free open source software, and here we offer the same EHRServer, but in the cloud. So we manage all the infrastructure, and you get the same application, but we manage all the updates, all the database infrastructure, backups, etc. for you. And here on the Learn section, you can read some tutorials, some guides. Here we have some documentation here. Also on the Cabo Labs site, you can go here to products, and you can get more information about the EHRServer as an open source product, the cloud EHRServer service. Yeah, and if you go to the EHRServer, you will see some of the features. We will upload this new demo here, the video here, and here you have some information about what it has, what it supports, what paper, what helps you to understand the idea of the EHRServer, the scope of the EHRServer, what it covers, etc. And the guide, this is the latest guide. And right now we are working on the release of the new version, the 1.3 on our roadmap. And this is the conformance statement with OpenEHR. The EHRServer complies with the OpenEHR standard. And here you have more resources. You have our websites, our repositories, client code in JavaScript, in Groovy, PHP, etc. And as I said, it complies with the OpenEHR standard. If you don't know about OpenEHR, you can go to openehr.org and you will find the specifications here. Basically, they tell you how to build a good EHR with good characteristics and to be future-proof and interoperable with other standards, other formats, etc. So it's pretty flexible what you can do with OpenEHR implemented in your EHR. And basically, this is the user interface. This is the web console, the administrative web console of the EHRServer. Right now, we are showing the cloud version. This is a version on the cloud. And what is the purpose of the EHRServer? Basically, it is a clinical data sharing platform and management platform. So it is composed by a clinical data repository that complies with the OpenEHR standard and is what we call DNA, a vendor-neutral archive or clinic or repository that allows you to store the information in a vendor-neutral model. We don't define the model to store your data. You will have access to all your data in the OpenEHR format following the OpenEHR model. So this is very good. So you don't have vendor locking. That happens when you buy a new EHR that has a closed and proprietary model. To access your data, you need help from the software provider. This is not the case of the EHRServer. Also, because we implement the OpenEHR standard, the data that you have stored is interoperable. You can access the information, you can transform the information into other formats, other messaging standards. You can use HS7 or whatever to exchange information or to extract information from the EHRServer. Yeah. From the user perspective, here I'm logged in as an administrator, and I can do anything because I am a super admin here, and I can see all the organizations, all the accounts, all the EHRs. So I will walk through every section, and I will explain a little bit about each section so you can understand how to manage your data here and to get to know the EHRServer a little bit. And maybe it can apply to some project that you have. One use case that we have for the EHRServer that you can also find here on the Cloud EHRServer site, we have a use case map. One use case that we cover is to have a shared health record. That the idea is that you have several applications to record information, clinical information for the same set of patients. Maybe each application has is customized for every medical specialty, but you need to have the clinical information integrated in one repository. So the EHRServer can play the role of that central repository and can take information from many different applications and store the information integrated and following the OpenEHR standard. And that information can be accessed later in an integrated way from the REST API. I will do another video about the REST API to show you in technical terms how I can access the data from different EHRs and how I can use that information to feed other applications, even those applications for clinical recording. Also, we can use this as a backend for mobile applications. There are other use cases. So this is the dashboard. Basically, here I have a small counts on some of the data that we store on the EHRServer. Here we have a little bit more than 2K EHRs, clinical records. We have 18K, a little and a half contributions. Contributions are changes to an EHR. For example, when a clinician adds a new document to an EHR, that's a contribution. We have some queries. I will show you how the queries work. We have some templates. The templates are the definitions for the clinical documents, and also the templates follow the OpenEHR standard, and we have users there. And here below we have, for each organization in the system, the size of the repository of each organization. Yeah, these are test organizations that don't have data yet, and I have all the data in one repository that I'm doing some load tests here. So all the contributions are for this repository. Yeah, there is a get started guide here with some information that you can use to learn more about the EHRServer, how it works, how to use it. And you have the tour here. The tour really guides you through some important areas of the EHRServer web console, the user interface that I'm showing you. So following this, it just tells you different sections and what can you do on those sections, etc. So it's a quick tour from for the user interface. Yeah. One thing that I can do as an admin, I'm a super admin, I can manage plans, because this is a cloud server and we are providing a cloud service. The idea is that client will subscribe to a plan. So if they subscribe to a plan, they have certain constraints of use of the EHRServer. So you will manage this if you install the EHRServer on your servers and you are the super admin. If not, if you are a manager of an account and you are a client of us, you won't see this section. You will be associated with one of these plans. Yeah. Then on the account, I can see all the accounts on the system. These are clients of the EHRServer, and I can show you that, for example, the account that I use for testing, the Cabo Labs account, has different organizations inside. Each organization, the amount of space that they use, and the number of templates. These are clinical document definitions, and all the plans that they had in the history. I can see this for each account. So let's say we have a client that each year renews the plan, and maybe they change to a better plan with bigger constraints. It's really smaller constraints, so they have more storage, more templates, etc. We will see the changes through all those plans. Yeah, we will see the old plans and the active plan. But this is only for super admins. Then on the organizations, if you log in as an account manager, you will see all the organizations associated with your account. The idea is, if you're a software company and you have, let's say, 3 clients, you will create one organization for your company, and you will create 3 organizations for your clients. Your organization will be used by you for testing purposes, and the other 3 organizations will be used for each of your clients. So you can provide your clients with a backend and have the EHRs associated with each organization, and have all the test EHRs under your organization. So you will have 4 organizations. On the EHRServer, we use the organization as a container for EHRs. So each organization accesses their own EHRs, and one organization can't access the EHRs from another organization. Yeah. So here I can show you one of the organizations that I have for testing. Yeah. And here you will see the information about the organization and some numbers here about the transactions done by that organization. Each commit of clinical documents to an EHR that belongs to this organization will be counted here. Documents are the number of documents that are committed. In this case, each transaction contained 1 document, so the number of transactions and the number of documents are the same. And also we can see how much space that this organization used on the repository from the space that is available for this organization. And this comes from the plan associated with the account. We can see all the EHRs that are associated with this organization. We have 2K EHRs here. We will see the EHRs later. And we can see all the users that are associated with this organization. On the users, we have each organization has its own users, and we can see some basic information for each user, and we can manage. Let's say I can manage the user. I have some test users here, and I can see that this user has access just to this organization, the EHRServer, under the user role. If I want to make this user an account manager on the EHRServer, I can just edit the user, add the permission there. I can remove the other role on this organization. I can add also that permission on the other organizations, and I can also add different permissions of different organizations to this user, and I can update the user, and that's it. There I changed the roles and the permissions that that user has on all the organizations that are in the EHRServer, but I won't save that user. We also have some basic roles there. The admin is the super admin. We have the account manager that manages all the information about one account, and the organization manager just manages one or more organizations. So the account manager has more power than the organization manager, and account manager can manage organization managers, and users have the less power, and they can't access this user interface. They can access only by the REST API. So they will have only this role and won't be able to log in through the user interface. Then we have some access control here. This is also just for admins. This is a low-level permission set. So we know specific paths have certain permissions here, and I can edit these permissions, add, remove, etc. This is not so interesting, but now we'll see the EHRs. So here I can see all the EHRs from all the organizations because I'm a super admin. If you are logged in as an account manager or an organization manager, you will see here just the EHRs for the organization that you are logged in. Yeah, so that is a constraint. You can see only the EHRs for that organization. And here I can see the details about one EHR. Let's check this. And the EHR have unique identifiers. We have a unique identifier for the patient. The subject is the patient. And we don't store any personal information here. We don't store passports or national IDs or national documents or social security numbers, nothing here. We just have a reference to an external system, and the external system should store this identifier and make the link between the personal, the demographic information, and the clinical information that is stored in the EHRServer. We don't store any personal information, any demographic information, names, IDs, addresses, telephone numbers, emails, nothing. The EHRServer do not store that information about the patient, just clinical information. So this is the organization that this EHR belongs to, when this EHR was created, from which system, because we can create EHRs from this user interface, but we can also create EHRs from the REST API. And the REST API method is the recommended method because it allows you to create the record for a new patient and then create the EHR for that patient in the EHRServer from an external application. Yeah, so that is the idea. And here you can see a small chart with the dates of the commits to this EHR. So we have some clinical documents that were added to this EHR, and here we see the points in time that those documents were added, and below we have the details of those documents. So I can see that on some date, a document that complies with certain template, this is an OpenEHR template, was added to this EHR, and we can see, for instance, here the name of the person that committed this document. So we have here the names there, yeah, and we can see that this document was a new document because the change type is creation. If an external system sends a modification to a clinical document, here we can see a modification or amendment. Since clinical documents can't be really modified, what the EHRServer does is receives the new version and creates a new version of the clinical document. So the EHRServer stores many versions for each clinical document, and that complies with the OpenEHR versioning that is defined on the OpenEHR standard. It's part of the specifications. So what we do is we store all the versions. Let's say a document is committed to the EHR, but later a doctor detects that there is some missing data. They add that data and then they commit the document again. We don't generate a new document. We generate a new version of the same document that was committed before. So we can, a modification is when there are some errors. An amendment is where there is some missing information on the document. Yeah, and here are all creation, just that. We can, for instance, we can see this one. This is an encounter document with some information. So here's the date of the document. Here is the name of the person that committed that document. We see some text here. The text is in Spanish, but that is just content because the document was in Spanish. And we can see this is the user, the human format, let's say, and this is the XML is the computer format. So this is the source of the clinical document. This is the clinical document as it was committed to the EHRServer from a client application. So here we have all the data. This is the structure of a clinical document that complies with OpenEHR. These are all OpenEHR types. This is the structure of the OpenEHR clinical model and complies with the XML schema that was published by the OpenEHR Foundation. So here we have, for example, a diagnosis, and it's coded using SNOMED CT, and the OpenEHR model supports any terminology. That's a question that is asked a lot, if OpenEHR supports SNOMED CT or LOINC or ICD-10, etc. Yes, OpenEHR supports a type that it's called DB code text, and that can have any terminology codes here in any terminology here. Even custom terminologies, even your local terminologies can be in the OpenEHR model. Yeah, so this is a small document. This is a sample document. Here there is some free text information, but this complies with the standard. So this was committed there. And as I said, you can come here from the user interface and you can click on this plus button, and you will see that plus button on every user interface, and you can create a new EHR from the user interface. You just enter some ID of the patient. This is an ID that doesn't have any meaning. This is not the national ID, it's not the social security number, it's a computer, it's an internal, it should be a computer generated or internal ID. Yeah, and the organization that this EHR should be under, because each EHR belongs to an organization. So I can create from here just two clicks away from creating a new EHR for a patient. Yeah. Contributions are the changes for each EHR. I can see all the changes. I can see here the by month, all the changes. So I did a lot of tests this month, so we have a big rectangle here, but you will see different months of with different amounts. If next month I do another test, you will see another column here. Here is each contribution, and each contribution is a change to an EHR, a change set to an EHR, and that can contain one or more clinical documents. In these cases, these tests contain just one clinical document. And if I go to the details of one contribution, you can see the ID of the contribution, the EHR that contains this contribution, some audit information, yeah, so when this contribution was added, and the reference to the clinical document. And this is the same as we saw on the details of an EHR. So this is a contribution. This is the template. ID that this contribution complies with. So the templates are clinical document definitions defined by OpenEHR. You can see this was a creation, and also you can access the contents of the document compliant with the OpenEHR format, XML format, and the user view, the human user view here. Yeah. And that's it. There is not much about the contributions. The contributions are really logs about the changes to EHR. So you can do some audit here to check if you received all the documents that you should receive for the EHRs, and if EHR has the correct documents. So you can check all that information here, because you have all the information: who made the changes, when the changes were made, from which system. You have the EHR, you have the specific clinical documents that were committed to the EHR, etc. So you have all the information here. The versions are, as I said before, are the clinical documents that contain many versions. When a clinical document is created, it creates the first version. But here we can click on one clinical document and see all the versions that that clinical document contains. And here we have a basic information about the clinical documents. And you, as I said, the template defines the structure of the clinical document. So when you see a clinical document on the EHRServer, you will see for sure some template ID, yeah, associated with that clinical document. So I will go, let's find. I want to see other types of clinical documents. Let's see. These are all the same, follow the same template. I want to see if I can find another template. So there is an encounter with code diagnosis. I can see the clinical document, and here you will see all the versions. And you will see that if the clinical document has many versions, you will see one creation and then many modifications or amendments to that clinical document. In general, most documents will have just one version, and the rest will have one version and maybe one amendment or one modification. It is very strange that one, what we call event clinical document, event are, for example, documents about clinical encounters. Yeah, it's really strange that one event clinical document has more than two versions. Yeah, but OpenEHR supports other types of clinical documents that are the persistent ones, and the persistent ones, instead of being based on events or contacts with a clinician, are persistent in the life of the patient. So let's say if you have a problem-based clinical record, an EHR, you will have the list of problems as a persistent document. So in that persistent document, a clinician will add problems, will solve problems, will update the status of the problems, but it will be one list, one problem list per EHR, and many versions changing the status or adding new problems to the list. Yeah, that is supported by the OpenEHR standard. I don't want to enter into the details about the specification, because we have workshops and courses about that. Also from Cabo Labs, we offer training and coaching. So if you come here to education, you will find that We have several workshops and courses about OpenEHR and clinical database design and implementation, clinical modeling, etc. So we have a lot of instances to learn about the details, the deep details of the OpenEHR specification. But these are just some context information to understand what is going on here on the user interface. Then and also on the versions, is more for auditing. That other thing is you come here to check if one document has many versions. Why was that? Who made the version? What was modified? You can compare two different versions of the same document and see what changed, what was changed by the user that committed the second document, etc. So that is mostly for auditing and detecting possible problems and manage the clinical information correctly. The folder templates is a test that we are doing. The idea is that in the OpenEHR model, you can organize the clinical documents inside folders, and folders belong to an EHR. So inside the EHR, you can create a structure of folders, and you can associate clinical documents with those folders. That helps to organize the clinical documents, and also for quick access for some set of clinical documents that a clinician wants access to, because they will be able to create folders themselves and to change that folder structure for their patients. So this is just testing. This will be fully implemented not in the next version, but in 1.4, maybe 1.4 or 1.6. The next version will be 1.3, and we will have a lot of improvements in terms of robustness and security on that version, on the next version. So this will be implemented later, but the idea is you come here and you can see, and later you will be able to edit the structure from here. But and this structure will be available from the REST API, so you can integrate these folders into an end user application and then user interface. So you can show this to a clinician on a mobile device, on a computer. You can show this to them, and you can also provide them with access to the clinical documents that will be contained on this folder structure. Yeah, but this will be implemented later. This is just some tests that we did. And the queries maybe is the most important feature of the EHRServer, because it allows you to create queries from the user interface without writing any SQL. So you don't need to write any code or compile the application or write any SQL queries, etc. That is all done from the user interface. I will show you how I can create a query, and I will show you here that I have some queries already created, and I can execute these queries. I will explain what these queries are and what is behind this. So the first is on this interface, you will see the queries that are on these tables are organized in groups. And you can manage the groups from here. You have groups here, and you can create more groups. You can add a group. This is just to organize the queries, because some queries might have something in common, and you might want to, if you have, I don't know, 200, 300, 1,000 queries, you won't be able to manage all the queries if those are just on one list. So there's some organizational structure going on there with the groups. So here we have, since these groups are just names, and the names are in Spanish, but this is diagnosis, this is about conditions, this is about weight control, This is demographic queries. This is about medication, and also the queries that are not grouped on a group will be here on ungrouped. It's just that. And for example, if I take one of the queries for on the diagnosis group, I have here the diabetes query, and this query will return all the documents from any EHR that contain some diagnosis for some type of diabetes. Clinicians know that there are many types of diabetes, and for this, we are using SNOMED CT expressions. So I will show you what I mean. This is the details of the query. The queries are not stored, are not hard-coded in the code, are stored in the database, and we can get them and execute them. So this is why we can define new queries from the user interface. So what I'm doing here is I'm selecting an archetype, an OpenEHR archetype that models the concept of diagnosis. Yeah, this is the diagnosis concept. This path inside the diagnosis concept points to the specific node where the diagnosis is recorded. Is the specific code for the diagnosis. And here there is the condition that all the clinical documents returned by this query should comply with. So this, what it's doing is checking if the code of the diagnosis is, this is an operator that we define in the EHRServer. The code is in the SNOMED expression, and this is a SNOMED expression. And what this is doing is, this code is the code of diabetes mellitus, and this is the more generic concept of diabetes. And this can be any type of diabetes. So this lower than, what it's doing, this double arrow here is saying, I want all the descendants of this code, and this code is diabetes. So this is taking any type of diabetes. Yeah, so this is very, very powerful, because with these expressions, we can do a lot of complex filtering of data just with one expression here. We don't need to have all the codes for this concept for all the children of or descendants of the diabetes and put them all here. We just have the small expression, and this expression can be really complex. Yeah, and the terminology is SNOMED CT. So with this, we take those documents that have a diagnosis of some type of diabetes. For example, this other query has a more complex SNOMED expression there. This is, I want all the, this is infections of the respiratory tract. This is a relation. This is the cause should be equals to virus. So, and this is all the descendants of that. So this will return all the documents that have a diagnosis that is any type of infection of the respiratory tract caused by virus. So if you try to think about the amount of codes that you need to model that, there are many and a lot of infections of the respiratory tract caused by a virus, and having that on a query is not so easy. Yeah, and with this internally we are resolving this expression that is very complex, but it's very easy to express here, but it's very complex to resolve. And internally, the EHRServer takes the complexity and makes the query correctly. So you don't need to bother about that. Yeah. And about creating a query, these are queries that are already created. One thing, when you create a query, you can have a quick overview over the data that you have on the EHRs and calculate some quick indicators. So I can execute count here, and it takes some time. Remember that I'm checking these queries will be run against all the EHRs. I have 2K EHRs and 18K clinical documents, and this query runs in a couple of seconds. Yeah, it's running over all of those EHRs and clinical documents, and is counting the number of EHRs that contain a document with the criteria expressed by the query. In this case, any type of diabetes, diagnosis with any type of diabetes. In this case, is the number of EHRs that contain one document with any type of respiratory infection caused by a virus. And in this case is when you have a chronic kidney disease. And the quick counters there just give you some feel about the data and about the population that you have here. So this is very useful and just runs with one click. This is one thing that is really useful that you can do. And if you are doing research, this can be really useful. Yeah? And for creating one query, I need to switch the language because the queries depend on templates, and templates have a language associated with them. Since my tests that I did are in Spanish, I don't have any templates in English yet. I need to load some templates in English. So what I will do is, since I'm logged in right now in English, I will switch to Spanish. I will log out. And I need to switch to Spanish first. And that's it. It's the same user interface, just in Spanish. And there I show you another feature of the EHRServer, that you can have the user interface on different languages. We can translate this to any language. Right now it supports Spanish and English, but that can be translated. So this is the same interface. I will do a click on the plus button to create a new EHR, a new query. And I will say this will be, I don't know, overweight. Yeah. The type is when I want to define a condition over the information of a clinical document, should be composition. If I want to get just data out, I choose data value. Yeah. If I want to assign a group, I can choose the group from here. And I don't have any templates here either. Let me check. The templates are in English. I have some, maybe the templates are not associated with this organization. Maybe it's that. I need to check if or maybe it's not that. Let me check. I'm showing you since I'm showing you the development, the latest development version, maybe this has an error. These errors are just about the fonts. And let's see if here we get the templates. We are not getting any templates there. I need to check that. Let me see if I access with another, maybe with another organization. What I need is these templates should be in, maybe we have, I did a cleanup last week of the database, maybe these templates were not loaded correctly. Let me recheck that we have all the templates here loaded. I didn't update. We need indexes over those templates. Sorry. Yeah, we changed some templates. I did a cleanup last week. There we are. We have the templates there, but that was because I did a cleanup last week and forgot to reload the templates. Yeah. So we have overweight here. We select composition as our type because we want to define some criteria over the data on the clinical documents. And we have here a weight control template. This is in Spanish, but this is weight control. And so I can translate for you. I will just increase a little bit the screen size so you can see the details here. We have an archetype because templates in OpenEHR contain many archetypes. Archetypes are models of data structures that represent one clinical concept or clinical content. Yeah, so we have one here weight control template, and inside we have a body mass index, a body weight archetype, and a height archetype. And why do we have the height here? Because we need the height and the weight to calculate the body mass index. And I will choose the body mass index, and the body mass index has some internal structure here. And this data point that is quantity is an amount that has some unit, is the value of the body mass index. So I select those, so 3 clicks here, and we have magnitude and units. So I can define that the magnitude should be greater than, and to be to have overweight, this should be greater than, I believe, 30, something like that. Is 30 kilograms divided meters squared. And I can add that criteria. And if you can see here, we have 2 alternative units. These values are for the units. And these values come from the archetypes. We are not, we don't have any knowledge about the model. We just get information from the archetype, and we display the information here. So this is very useful because you don't need to type the units by hand, and you know that these units are valid because the archetype defines that unit. Yeah, and what is on the archetype is the truth, is the model. So we can add that criteria, and here is the body mass index archetype. This is the body mass index concept. This is the path to the specific value of the body mass index. This is the name of that node in Spanish. This is the type of that node in the OpenEHR model, and this is the criteria. I want the magnitude to be greater than 30, and the units will be equal to that unit. Yeah, and I can, for example, choose from here what is the output format for this query. It can be XML or JSON, and I can test. This is the test button, and this will display if I want to test this query against one EHR. I will check one EHR here, but if I don't choose any EHR, this query will be executed against all the EHRs that I have access to. And I can also add some date filters here, etc. And if I execute this, and this can take some time, but not, we have results almost immediately. And remember, this is running over all the EHRs. We have 2K EHRs right now, and over all the clinical documents, we have 18K. And this took maybe less than a second to run. And this format, and you can see this is not the content of the clinical documents, it's just a reference to the clinical documents that contain if you can see the template ID is weight control. This is the weight control in Spanish that contain a weight measure that is above the body mass index is above 30. So that means that that person was or had overweight at least at the time of the record, and we can see the time of the record here. Yeah, so we have the reference to each clinical document inside an EHR. This is the EHR ID, and we have one or more documents under each EHR, and this is the ID of the clinical document. If I want the contents of that clinical document that contains the value of the body mass index, I can, with this ID, I can query the REST API and get the content of that document. That is easily done. And this is the same format that a developer and an application will see executing this query from the REST API. And I will show you on the next demo how queries can be executed from the REST API. So this is pretty simple. In a couple of clicks, I define a query. And if I go here, I can create the query and save that query. This query is just a test query, so I don't want to save it. Quickly, I can get vitals. I want data out. I want to delete the current query. Okay. And I can choose, let's see if I have any. I'm not sure if I have any records of vital signs here. Maybe I have. But I can have the weight. The weight, I have it here. And I can choose the weight from there. And I can add this. And what this means is I want from the weight archetype, I want the value of the weight, and that will be quantity of the quantity type. Yeah, and I can return that in JSON. And I can group the results. I can group the results by clinical document, by the same type. It will be grouped by this path, and without any grouping. If I group by path, I will test that query. I will test that query against one EHR. Let's see if I can execute that EHR. Doesn't have any weight. Let's check. This EHR, I choose this EHR, and this EHR has some weight data. There are 3 records here. And this is just test data, so the records don't make sense. Yeah. So we have the EHR ID here. We have here the information about the OpenEHR data point. We have here the type in the EHR and the OpenEHR model. Here we have the name of this data point in Spanish and English, so we can show this on different user interfaces in different languages. And here we have the magnitude. This is the value of the weight, the units, and the date when this weight was recorded in the EHR associated with this patient. So this is also the same format that a developer will get from the REST API when they execute this query. Yeah, so this follows the data from the OpenEHR model. And it was really 2 clicks and boom, get the data. Yeah, so it's really that easy. I can save this query, and this query will have a unique identifier. And with that unique identifier, like this one, a developer that has access to the REST API can execute that query, and can execute that query over all the EHRs inside one organization, or they can execute this query against one EHR for one patient. So they can get all the records of the patient that had diagnosis of diabetes or respiratory infection or overweight, etc., etc., etc. Yeah, so this is just a couple of clicks away, and you can create any queries that you want and make the queries as complex as you want, and those queries will be instantly accessed from the REST API. And you don't need to write code or write queries. You don't need to recompile the EHR and do a deployment or QA or test, nothing. It's just a couple of clicks and you have new queries. Yeah. So it's as that easy. Yeah. And then we have the EHR queries. This interface is in Spanish, but I will explain. The EHR queries are a combination of those other queries that I showed you before. So if I want to query, for example, I can define a query that gets records from patients that are masculine and older than 35 years old. I can have another query to get the records about diabetes. And I can have another query to get the records about obesity or overweight. Yeah. So this query is just that. I want masculine patients older than 35 with diabetes and obesity. Yeah. And if you see the details of this EHR query, we have 3 queries here, and each query is one of those conditions. What this does, if I execute this, is this execute these 3 queries against all the EHRs, yeah, in the database, and you will see here that the number of results, yeah, a little bit above 400, and this will be merged. The results of the will be intersected. So this will get all the diabetes, they will get all the obesity, and this will get all the masculine older than 35. And the results will be intersected together. So the results will match with the 3 conditions on this on the results. Yeah. So and we have here as the result of that the EHR IDs of the patients that comply with these 3 conditions. So I know for sure that this patient is masculine, older than 35, that has diabetes because diabetes is a chronic disease, and had in his or her history, in this case, are masculine because I said that on the query. So on his history, maybe they are still obese, or they have overweight still, but maybe that is not the case. But they had some record of obesity. Yeah, and that is the result. What is the use case for this? First, you can execute this from the REST API and get the EHR IDs of those patients that match your criteria. Second, this can be used to select patients to participate on healthcare plans. Yeah, you have maybe a plan for obese people that are young and masculine because that is a risk factor, etc. You can set here your conditions, and you will get right away a list of the possible candidates to participate on that plan. Yeah, and that is prevention. This is for wellness and to get values right. Yeah, people that is obese, or they have high cholesterol, they have high blood pressure, etc. So you can query for those conditions. Then another use case for this, and this is very useful for that because it's very difficult to get patients, is to get a list of patients that comply with certain condition for clinical trials. When you have a company that wants to test a medication, a new drug, let's say for cancer, here you can define queries for people with certain gender, certain age range, comorbidities like overweight or diabetes or high blood pressure or high cholesterol, etc., and also specific types of cancer, yeah, on certain places and specific types of tumors, etc. You can choose, you can create those conditions based on EHRServer queries and using, of course, the SNOMED-CT expressions. You have a lot of clinical knowledge on the SNOMED-CT expressions, and you can get a list of patients that you can invite to participate on those clinical trials. And that is very difficult to do because it requires a lot of time of people reviewing paper records to find patients with certain conditions. And with this, you have all the information standardized. You can create new queries with a couple of clicks, and you can create also EHR queries that combine those simple queries with a couple of clicks, and you can execute that in a couple of seconds. And that will give you a full list of results really quick for those use cases. And maybe you can think of more use cases. So that is very useful when I demo this for possible clients or for the talks I give for universities or certain events. They really like this feature because it doesn't require a lot of effort to do, and it's very easy to define new queries. The idea is behind, we can do this because behind we have OpenEHR, we have SNOMED, so we are based on standards. We have a lot of field covered by those, but by implementing those standards. This will be more difficult to do if we don't use standards and good practices. And remember that the EHRServer has started as a research and development project, and it grew and improved through trial and error and investigating new ways of doing things and better ways of doing things. Most of the knowledge that I gained designing and implementing the EHRServer was put on the courses that we give. So the courses that we give from cabolabs.com, some of them are based on the knowledge that I developed designing and testing the EHRServer and creating new features. So yeah, as a summary, the querying functionality, the querying feature in the EHRServer is really a huge feature, a huge functionality. Is really useful and really easy to use. Yeah, and the nice thing is when you get used to defining the queries in this way, all the queries will be defined in the same way. So it will be really easy for someone to get to understand how this works. And after they understand how this works, they can create any query, and will be in a couple of seconds. And that's it. You will get the data right away, and you won't have any downtime on your applications or end user systems because you need someone to develop your new queries, to do some testing, QA, deploy, compile and deploy a new version of your application just because someone needed an extra data field or an extra query. With this, you can comply with new requirements in a couple of seconds. Then we have the, I won't switch to English because we have just a couple of more areas to explore on this user interface. I will explain this. This is the list of templates. Here is where you manage all the OpenEHR templates. You can create templates using the OpenEHR modeling tools. You can create archetypes first, and then from the archetypes, you can create using the archetype editor, the archetypes, and then using the template designer, you can create templates. And these are applications that are for Windows only right now. I don't think they will port these tools for other OSs, but I have a a Windows virtual machine and I use the template designer on Windows. But you can create archetypes and templates using these tools and then upload to the EHRServer the template. You just choose the file, the template gets validated, and you will have your template loaded in the EHRServer. What this does is this defines a new clinical document structure. So you can start right away committing new clinical documents with new structures. So to support new structures of clinical documents or new types of clinical documents, you don't need also to write code or compile or redeploy the application. You just upload a new template and that's it. You will start committing documents that complies with the new template right away from the REST API. Yeah. I will show you one template. Templates have a language associated with them. So we have some Spanish and some English templates here. I will show you one template. This is some information about the template, the ID of the template, the language, have a unique identifier internally, the root archetype on that structure. You have the archetype ID there. And what we do in the EHRServer, and this was an addition on this new version, is that we manage reviews or revisions of the templates. Let's say you are developing a new system. So you create a template, you upload it to the EHRServer, and then you continue the development and you find that you need to add a field on that template. You add a field on the archetype, then you update the template, and then you upload the template to the EHRServer. You don't upload the template as a separate template. You can upload the template as a new version of the existing template. So the EHRServer manages the different versions that are really revisions of the same template internally, and it maintains those versions for you. Yeah. So on the next version, what we will add is what we don't have right now is a screen to show you each template and all the revisions for that template. And you can see the details for all the revisions. Right now, you can see the latest version of each template, and you can see how many revisions each template has. This has just one revision, is the original version. And the templates in OpenEHR are just a big XML that has all the structure defined. These are all types of the OpenEHR clinical model, and has all the structures, constraints, and terms defined. And this is like a big merge of all the archetypes. Yeah, so you have the structure there, blah, blah, blah. I won't show you the details because it's boring, but it's just a big XML there. And this is used to validate the clinical documents. And also we use the metadata here. This is metadata for the queries. All the queries that you can create when you select a node, a data point, and you define a constraint over that data point to filter some data, those filters and those data points are based on the structure of the template. So the template is core for the EHRServer. When you start working with the EHRServer, you will start creating organizations, creating EHRs, and then creating templates or uploading templates, and then creating queries, because queries are based on the structure defined on the templates. We have a list of data indexed. This is the data that we extract from clinical documents, and this is also used for querying. This is not so useful to see because this is used internally. This is just for testing purposes or debugging purposes. Yeah, I added this to the user interface because it was easy to test if some data point was indexed or not. We have a notification feature here on the application. We can create a new notification, and we can, for example, if in your organization you have 2 managers, you can create a notification so the other manager sees that notification when he logs into the web console, into this user interface. So you can say, hey, I uploaded the template, blah, blah, blah. So don't upload it, or I will test with that template, etc. So, or my development team is testing, don't delete that template, etc. So you can communicate with your users through the notification feature. And this was implemented also for the cloud EHRServer when I need to manage accounts for different users and different organizations. And sometimes I need to communicate that an update was done, or that I will do some testings, etc., or that we will do an event or a demo based on the EHRServer, etc. So this notification doesn't have to do with clinical information or OpenHR or nothing, just a feature of this system. And then the latest section is the records. The records is just a list of logs, and I can see here all the actions taken by each user. And here, all these actions are me. This is my IP, my public IP. And here are all the sections that are accessed because I'm doing this demo. So this is basically recording each of my actions. And this is useful, let's say, to check what users do on the web console, or what users do on the REST API, because here we can see also records from the REST API. So I can check if a client was accessing things that they shouldn't access, for example. So this is for audit or security purposes. Yeah. Also, I detected that some hackers wanted to break in the EHRServer, and the main the main way that I found that they tried to access the EHRServer was these logs, because I detected a pattern on the time they accessed and a pattern on the IPs they used to access. For instance, if you see these IPs, you will see that are the same IPs from the same place, and they are trying to access, and they are just different IP numbers or interface numbers on the same network. Yeah, and I can check if these IPs come from IP to country. We can use, for instance, a service online to check the country, and this is United States, and this is Google. So these are not attacks. I can check these IPs, and this is Google trying to index this web application, because this is public, so they are trying to index as it was a website. Yeah, but I can see other actions. This is me. This is my IP, my public IP. This is me, my IP. Still me there, blah, blah, blah. But you can see what this is about. Yeah, this is about control. This is about knowing who access what and when, and from where. And this is from France. Yeah, so you can check the IPs, and you can see if you have real users accessing your system, or there is some hacker or some person trying to access. And you can see that after the login, they did nothing. So this is a failed attempt to log in, and we can see other logs on the server and prevent these people to access again. But if there are real hackers, they will change the IP, and they will have different access patterns. So what we can do is that we can try to prevent them from accessing and detect if they had access or not to the EHR server. So as I said on other video, any application that is public is not secure at all. It's a time matter that someone accesses. So we need to know that someone is attacking us, and we need to take measures based on the attack patterns that we find. For instance, if I don't have any clients on France, I can block the whole country, IP ranges. I can block the whole country, and I won't receive any requests from there. Of course, if the hacker is not from France and is using a botnet from France, etc., my attempts won't matter really. So we are trying to detect if someone is trying to access and if someone already accessed the server. So we need to strengthen the application, the tools, the server, but also the processes. And the processes, I think, is the most important thing about security. For instance, I check these logs daily, and sometimes more than once. So doing that, I can detect if someone is trying to access the server. And I can block, if I receive a pattern on the IPs, I can block that IP. If there is another pattern, like the actions that they want to access and with the IPs, I can block that. I can figure out how to act or how to react if I receive the attacks. So this is basically for that, to know who is doing what, from where, and when. Yeah, it's just that. Yeah, and with that finishes. We have just the last feature is that you can send feedback to us or questions. If you go to the menu here and you click on help, you just write a message to us, and you can access our groups on Facebook and LinkedIn. And I will answer. If you ask here, I will answer right away. So we have a little help there going on, a little communication there. Yeah, and so that's it. This is the full demo of the web console of the EHRServer. Remember, on the Cloud EHRServer site, you have more guides, tutorials, etc., some definition of use cases, so you can check if some of these use cases are needed by your project. Yeah, so you can check here. We have a lot of information, and you can get in contact with us from here. And also remember that from Cabo Labs, we give consultancy services. We help you create your clinical information systems, integrate your clinical information systems, implement different standards for different areas on your clinical information systems, etc. And we also give training, education, and coaching if you need that. Yeah, that's all for me. Thank you very much to watch this video, and this demo will be uploaded soon to the EHRServer page here. So I will publish when that is uploaded here. Thank you, and have a good day.